Welcome back. So, in our previous session, we have discussed about the electric charge and the properties of charge, and also about the Coulomb's law. Now, in this session, we shall discuss about the electric fields, electric field lines, and about the electric flux. So, for a recapitulation purpose, Coulomb's law, which states that the force of interaction, Coulomb's law, which is an experimental law. Okay, so it states the force of interaction between any two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance of separation between them. Suppose we have two charges Q1 and Q2 separated by a distance r. We have our origin at the point Q1. So the force of interaction between the two charges is directly proportional to the product of the charges, that is Q1 into Q2, and inversely proportional to the square of the distance of separation between them, that is mod r square, that is the magnitude of r square. And the direction of the force is along the line joining, and Q1 repels Q2. Okay, so in SI system, this is the constant, proportionality constant. In general, you can take it as K. Okay, so the value of K in SI system is 1 by 4 pi epsilon naught. Epsilon naught is the permittivity of free space. Okay, now electric field. Suppose we have some charge or charge distribution. So it will for this charge distribution, we have some amount of electric field around it, and if we put another charge in any region, it will experience some amount of force due to this charge distribution. So the region is called the electric field, and the amount of force experienced per unit charge, per unit test charge, is the strength of field at that point. So electric field is at any point, is defined as the amount of force experienced by a unit positive charge placed at that point. Okay, so electric field for any charge or charge distribution, suppose we have a charge capital Q here, or any type of charge distribution, say Q1, Q2, Q3, a discrete set of charges. So for this, these are called the source charges. Source means it produces the electric field. Okay, Q produces the electric field. This distribution produces an electric field around it. Okay, so if we put, so these charges are called source charges. If we put another test charge, suppose small q, then it will experience some force. Small q will experience some amount of force due to capital Q. So there is a presence of electric field in this region. Okay, and what is the amount of electric field? It is the force experienced by a unit positive charge placed at this point. Okay, for simplicity, let a point charge capital Q at the point O plus Q at the point O. We are interested to know the electric field at a distance r, so r is the position vector of the point P. Okay, so we are interested to know the electric field here. Okay, so for which we have to place a unit positive charge, that means 1 coulomb positive charge. What is unit positive charge? 1 coulomb positive charge. We have to place 1 coulomb positive charge at the point P. So the force experienced by this 1 coulomb positive charge, that is unit positive charge, at this point P is defined as the electric field at this point P. Okay, so what is the value of the force in SI system? F equal to 1 by 4 pi epsilon naught Q1 Q2 by r square. And what is the direction? Plus Q will repel 1 coulomb positive charge. Okay, so the direction is along r. So this is defined as the electric field. Okay, the force experienced by this 1 coulomb positive charge is defined as the electric field at the point P due to the source charge capital Q. Is it clear? So this is given by 1 by 4 pi epsilon naught Q by R square into R cap. So electric field at any point is defined as the amount of force experienced by a unit positive charge placed at that point. So this is the force experienced by a unit positive charge. Okay. So now 1 coulomb charge is a huge amount of charge. So instead of taking 1 coulomb positive charge at a particular point, we take a small amount of charge. Okay. Suppose this is capital Q. We place a small amount of charge delta Q. Okay, plus delta Q at the same point P. Okay, we place a small amount of charge delta Q at the same point P, and this is our origin O. So what is the force instead of delta Q, let small charge Q plus Q. Okay, so what is the force according to Coulomb's law? The force experienced by small q due to capital Q is F equal to 1 by 4 by epsilon naught QQ by R square. Let it K. The constant is K. Okay. So QQ by into R cap. So this is the force experienced by small q due to capital Q, and the direction is along R. Okay. So this is the force experienced by small q. So what is the force experienced by a unit positive charge? Force experienced by small q is this. So the force experienced by unit positive charge is defined as electric field. So that is equal to F by Q, and it is given by isn't it? We have defined the electric field at any point as the force experienced by a unit positive charge, and this is the expression of force experienced by a charge Q. So if we divide this expression by small q, then we will get the force experienced by a unit charge, unit positive charge, and that is given by E equal to K Q by R square into R cap. Okay, so from this relation we have E equal to F by Q or F equal to Q into E. Okay, where E is defined as the electric field at that point. So the magnitude of E, that is 1 by 4 pi epsilon or K Q by R square, is known as electric field intensity at that point. And electric field also contains the direction, and it is directed away from the origin along the line joining of the two charges. Okay, so this is the expression for the electric field. So what is electric field? Electric field is the force experienced by a unit positive charge. It is the force on a unit positive charge. Okay. Okay. Now this is the expression of electric field in SI system. This is 1 by 4 pi epsilon naught Q by R square for a point charge. Okay. And in CBSE system, it is Q by R square into R cap. This is known as source charge. This is known as test charge. Suppose we are given a problem. Okay. So this is 2D, let it D and D, and this is X. We have two charges, each of plus small q, and we are interested to find out the electric field due to these two charges at the point P. Okay, what is the electric field at the point P? And what is its direction also? Okay, so first of all, what is the electric field? So first of all, to find out the electric field, we have to think a unit positive charge at this point. Okay, so plus small q at the point A will repel this plus 1 coulomb charge in this direction. So this is the electric field at the point P due to the charge plus q at the point A, and this charge, this plus q charge, will repel this 1 coulomb in this direction, isn't it? Along the line joining. So this is EB, that is the electric field at the point P due to plus q charge placed at the point B. Okay, and the resultant electric field will be the vector sum of the two. Okay, so this is the direction of the net electric field E, isn't it? So what is the value of electric field? What is the value or magnitude of the electric field? At the point P due to plus q charge. I am interested about the magnitude only. Okay, so it is K Q1 Q2, that is small q, into 1, that is small q, by distance, that is AP square, and EB equal to, that is the electric field at the point P due to small q placed at the point B, and it is given by K Q1 into 1 by BP square. Okay, so AP equal to BP, and these two distances are equal. Okay, I haven't said this before, these two distances are equal. Okay, so AP equal to BP. So magnitude of EA equal to EB. Now what will be the vector sum of the two? So vector sum, if this angle is theta, then this is theta. If this is theta, then this is theta. So it is 90 minus theta. It is also 90 minus theta. So both are if this is theta, if this is theta, then this is also theta, and it is 90 minus theta. Okay. So the angle, let it alpha equal to 90 minus theta. Now net magnitude of the, first of all find out the magnitude of electric field. So E square equal to EA square plus EB square plus 2EA EB cos alpha. Okay, so E equal to root of this. Now magnitude of EA and EB are equal, so we can write EA square plus EA square plus 2 EA into EA, as EA magnitude of EA and EB are equal, into cos 90 minus theta. Okay, so this is 2 EA square, and here also 2 EA square. Take 2 EA out of the root, so this is root 2 EA. Write it in this way, EA so cos 90 minus theta is sin theta. Okay, so this is the magnitude of electric field, and the direction is along OP, CP, along CP. Okay, so this is the magnitude of the force, and it is along CP. So this is E equal to 1 by let it K, Q by, what is AP? Value of AP equal to x square plus d square root, so x square plus d square, so AP square equal to, so the magnitude is given by x square plus d square into root of 2 into 1 plus sin theta, isn't it? And the direction is along CP. Okay, so this is all about the electric field. Now okay, take the same example. Suppose two charges plus Q and minus Q are separated by a distance 2D, and we are interested to find out the electric field on the perpendicular bisector of the line joining between the two charges. Okay, we are interested to find out the electric field on the line joining on the perpendicular bisector of the line joining of the two charges. Suppose at any point P. Okay, so this is D, this is D. Let the point is C, and this is A and P. Okay, now to find out the electric field at the point P, first step is that we have to think a unit positive charge. We have to imagine a unit positive charge at this point P. Now this plus Q charge will repel, this small q charge will repel this one in this direction. Okay, and this small q charge will attract, this is a negative charge, this is a positive charge, so this minus q will attract 1 coulomb positive charge towards it. Okay, if the angle is theta, then this is theta, and this is also theta, this is also theta. Suppose this is EA, suppose this is EB, then this is EA cos theta, and this is EB cos theta, and this is EB sin theta, and this is EA sin theta. Now these two components EA sin theta and EB sin theta will cancel each other, because in the previous problem, from the previous problem you know that EA equal to EB, so they will cancel each other, and these two component, that is EA cos theta and EB cos theta, will be added. This is EA cos theta and this is EB cos theta will be added. So the net electric field at the point P due to this two charges, this charge distribution of plus Q and minus Q separated by a distance 2d, is given by E equal to twice EA cos theta, twice EA cos theta, because EA equal to EB. For simplicity, EA cos theta, EA cos theta plus EB cos theta. Okay, that is equal to 2 EA cos theta. As EA equal to EB, so this is 2 EA cos theta. So this is equal to 2 into K Q by AP square, Q by AP square. Okay. EA Q1 Q2 by K Q1 into Q2 by R square. R is AP. Is it clear? So this is AP square. Now cos theta. What is cos theta? Cos theta is base by hypotenuse. So this is if it is theta, then this is AC by AP. AC by AP. So put this value 2K AC by AP. So 2K AP cube into AC. Now 2K AP equal to x square plus d square whole to the power half. X square, this is x square plus d square whole to the power half. So 2K cube x square plus d square whole to the power 3 by 2, half whole to the power half. AP equal to, so AP cube equal to whole to the power 3 by 2. Okay, and AC equal to D. So this is Q into D, and the direction is along, suppose this point is AM, so it is directed along PM, and this is opposite to AB. You can write it also as BAB. So it is directed along AB, because AB and PM are parallel. Okay, so this is all about the electric field. Okay, electric field is the force experienced, electric field at any point due to any charge distribution is defined as the force experienced by a unit positive charge placed at that point. So this is the electric force per unit charge. Okay, and the direction, you can find out the direction from Coulomb's law. If the charges are like charges, then it will repel, and for unlike charges it will attract. So in the next session we'll discuss about the electric field lines. Okay.